last year, Peter, when my room was like, and yeah, Jack.
Oh yeah.
My room was wrapped up.
And the board had like
a whole, yeah, you too, yes. Like I couldn't do anything because my whole desk was covered.
You gotta come up with something.
everything was wrapped as a present.
Everything was wrapped as a present. The phone rang and I was like, gotta answer the phone.
Oh yeah, that's right.
All right, I guess I should let the other kids in, huh?
Did you guys unwrap or did you get other people to do it?
I eventually did it like a little bit at a time whenever I needed something. I just like unwrapped it as I needed it. And then I think by the end of the week,
Straw did some of it, I think, right?
Yeah. yes, because he had to help.
You did.
Yeah. All right. This whole attendance thing.
I found it was easiest to make everyone virtual and just go back and have to change it. But yeah. All right, this one.
See ya. All right. Good morning, everybody at home. How are you doing today?
Good. How are you?
Okay. Thank you for responding. I just want to make sure you guys could hear me. We're good. We're good. Good to be in school. Exciting to be back in school. We are going to look at a couple of problems from the homework. I think 27 and 33 from the homework. We're going to talk about a reference angle today, which we've really been using. So we're just giving it a name, a formalized name. We're going to continue finding trig functions for any angle, which was part of the homework over the weekend. And then if we have time, I'm being fancy and calling it an exit ticket, but it's just kind of like a summary of reference angles and trig functions to start preparing for Thursday's test. So if we get to that, you'll see it will be posted on Google Classroom, but it's more of like, it's not a quiz. We're going to do it together. And if we don't get to it today, we'll do it tomorrow. But it's more of a summarizing concepts that we've been looking at and working on. So today is the last book assignment before your test on Friday. Tomorrow and Thursday, we will be having 2 different review worksheets. Test on Thursday, sections 4.1 through 4.4. The review worksheets that you turned in for 4.1 through 4.3 that we're due on Friday are graded. You should have gotten them back. Please look at them because I actually went through and I wrote on them. So I made corrections, I wrote on them as if I was grading like a quiz or a worksheet if you were in class, and I collected it and I looked at it and graded it and made comments on it. So there are comments, physical comments and corrections made on that. So please take a look at that because there was not an answer key posted for that, and that was totally my fault. Forgot the answer key. So please look at the assignment from Friday so you can get some feedback from that. So anybody have questions? No? Cole, is your birthday?
My birthday was a
couple weeks ago.
December, yeah.
Okay.
I took off that day.
Okay. For some reason, I was thinking it was around now, but I guess not. Somebody else must have to look. Okay. So if you want to look at your homework, we're going to take a peek at that first, as I said. We're going to start with 27 and kind of just talk about what this question is asking for. And then we're also going to look at number 33 and see what that one's talking about as well. But the directions want you to find the values for the 6 trigonometric functions. And question 27 gives you the sine of some angle is equal to 3/5. Now we're not finding the angle. And unless it says to find the angle, you do not need to find it. When it says to find the value of the trig functions, you want to find what it would be equal to. So the value of the trig function, that's 3/5. So the value of sine is 3/5. It says that our angle lies in the second quadrant and the sine is equal to 3/5. So we're going to make ourselves a little diagram down here. So again, you don't need to find the value of the angle. So it would say find the angle value if you had to do that, or just trying to find the value of the function. All 6 functions, actually. So draw yourself a triangle. And please draw yourself a triangle. Even if they gave you an ordered pair, like the first group of problems gave you an ordered pair, draw yourself a triangle to represent this situation. So it says our angle is in the second quadrant. So that means that, oh, thanks. I appreciate it. It does. Thank you. So we are going to have the terminal side of the angle be in the second quadrant. So when they give you that information, the theta or the angle lies in the second quadrant. That's where the terminal side of the angle would lie. So it's going to go from the origin, and then the terminal side of the angle is in the second quadrant. So when you draw your triangle, Jack, you know that the sine are what 2 sides of a triangle? Right, opposite and hypotenuse, or now we're going to use y and r. Thinking about that this triangle is in an xy axis. So I'm going up, make that a little better, 3 spaces, and that's y. The radius is 5, so that's r. But sine is no longer just y. So it's y when we're on the unit circle, but for any other function, it's opposite over hypotenuse, or it's the y over the r. We need to find the x value, and to find x, you can use Pythagorean theorem. So we have one side is 3 squared. I don't know my other side, but that should be equal to 5 squared. So we have the height, we have the radius, or we have the y and we have the radius, we have the opposite, we have the hypotenuse. They all mean the same thing. And then we have 25 minus 9, which is 16. And when we take the square root, you get a 4. Except that 4 is not 4 because it's on the left side of the graph. So that 4 is actually negative. Yeah, so it's actually negative 4. So drawing the triangle is important so that you can see where it's located, but also what should be positive versus negative. The radius is never negative because the radius is the distance of the circle. The reason x is negative is because it's on the x-axis, the negative side. So it's still a distance. The negative just is the location of that distance. So now you're asked to find the other functions, which would mean I need cosine and tangent. We would need the secant and the cotangent, and then we'll put the cosecant on the side there. So the cosine is x over r. The tangent is y over x. Trying to get you to think of like the definition of a trig function. So if we're looking at the numbers, cosine would be negative 4 over 5. The secant is its reciprocal, so if I just flip that around, I have negative 5 over 4. And just flip it. Don't think of it as 1 over the value. Think of it as a true reciprocal, just flipping the fraction that you have. Because the secant is r over x. So you're just taking those values and flipping them. The tangent would be negative 3 over 4. The cotangent is the flip, so negative 4 over 3. And again, that's x over y. And then the cosecant is the reciprocal with the sine, so that would be r over y, and that's positive 5/3. That one's the only one that should be positive along with the sine. All the others are negative because it's in the second quadrant. Questions? All right, so the other problem was number 33, and this one you definitely had to use some like logical referencing. It tells you that the cotangent is undefined and that your angle should be in between pi over 2 and 3 pi over 2. All right, so I'm going to draw myself a little picture again. Cotangent is undefined. And my angle is supposed to be between pi over 2 and 3 pi over 2. So somewhere in this area here would be where the cotangent has to be. Cotangent is undefined. So thinking about what I have up above, cotangent is x over y. So we want the cotangent to be undefined. Cotangent is x over y. Joe, why would a fraction be undefined? Yeah, the denominator would have to be 0. So my y value would have to be 0. If y is 0 as an ordered pair, what would the x value be? So think about this. When is y 0, and what would its matching x value be? Peter, do you know? Yeah, when x is equal to 1 or negative 1. So if it's 1 over 0, it's undefined. If it's negative 1 over 0, it's undefined. Well, my x, if it has to be between pi over 2 and 3 pi over 2, my x is going to have to be negative 1 for me to have a value in that location. So if I go over to the point negative 1, 0, then my cotangent is undefined. And that happens at the value of pi. So this question more related back to the unit circle and not drawing a triangle. So the cosine or the cotangent is undefined when the y is 0. Y is 0 at positive 1 or at negative 1. And that's either on the positive x-axis or the negative x-axis. So now you have an ordered pair. You don't have a triangle. So this was like there were 3 problems that we did on Friday at the bottom of a screen or a slide that we looked at. So once you have the ordered pair, then again, you're finding the sine, which is 0. The cosine is negative 1. The tangent, now that I know that ordered pair, tangent is y over x. Well, tangent's going to be 0. And then the secant is undefined because 1 over 0. How about the cosecant is undefined, 1 over 0. The secant is negative 1. And then the tangent would be undefined. So anything at pi is going to give you an undefined value for tangent, or for cotangent and cosecant, because the y is in the denominator of those fractions. Questions? So today we're going to work with something called a reference angle, which I said we actually have been doing, we just didn't call it a reference angle. So section 4 is kind of more of like a summary section, pulling things together. So if you can find your notes.
I have a question about 29.
Yeah.
So like because I was like comparing what I got with the back of the book, and like what the back of the book said was like weird because it didn't really make sense. It says that the sine of 0 or the sine of the angle is less than 0. So wouldn't it just be negative 15 and then 58? The back of the book is like a fraction.
Correct, because the sine is y over r. So the sine is only the y value when you're on the unit circle. So if it's less than 0, and this is y over x. So my triangle would be in the 4th quadrant. My y value is going to be negative 15. My x is positive 8. And then if I find the radius, 8 squared and 15 squared is the radius. So what, 64 and 225? At 289? So I have a perfect square root. 17, thanks, Jeff. So we're taking the square root of 289, which is 17. So the sign would be y, which is negative 15 over 17. So it's only the y value when it's on the unit circle. Otherwise, if the radius is different, then that radius is part of the sine function. So that's why the back of the book had fractions in the answer. Same thing with cosine. So the cosine would be 8 over 17, not just the 8. So in the unit circle, when the radius is 1, we still are taking like y over r, but the radius is 1. So that's why it's just the y value for sine only on the unit circle. Good question to ask, Peter. Anybody else have questions? All right, so we are going to go to talk about these reference angles. And literally, like, you're using these as a reference, like as a guide to help you work through trig functions. So a reference is a guide, it helps to kind of work through things. So a reference angle is a positive angle it connects the terminal side and the x-axis, or to the x-axis. So a reference angle is a positive angle that connects the terminal side of the angle to the x-axis. A reference angle is always less than 90 degrees. It's always acute. We use reference angles to help us find values for angles greater than 90 degrees or less than 0 degrees. So I'm going to draw, again, a little diagram. Everything in trig comes with a picture. So if I have an angle in the second quadrant, place it in the second quadrant. The reference angle is the angle that connects the terminal side to the x-axis. So it's this little angle here. That's our reference angle. A reference angle gets a specific notation. So here is our angle theta, whatever it happens to be. The reference angle is called theta with a little apostrophe after it. It's called theta prime. That little apostrophe is a prime symbol. You'll use that a lot next year in calculus. That relates the initial angle to the reference angle. So it shows that there is a relationship for each of those. They're kind of together as an angle.
What's the difference between that and the supplementary?
Well, that is a good question. So a supplementary angle, two angles that add to be 180. My reference angle could be in the third quadrant and it could be past 180. So that could be my initial angle. The reference angle is this little angle right here. So the reference angle, in this case, a supplementary angle has to be two positive angles that add to be 180. So if my angle is past 180, it can't be supplementary because it's beyond 180.
So if it were in the fourth quadrant, would it connect to the right side?
Yep.
Okay.
Yes.
Because it always has to be.
Yes, it always has to be acute, yeah. So if it's in the fourth quadrant, these are all good questions. So here's my fourth quadrant angle. So there's my angle. And then the reference angle would be that little guy right there. So reference angle can kind of be in different locations, or a supplementary angle, two angles that add to be 90 degrees. But the reference angle is just an acute angle, a small angle that takes you back to the x-axis. So we're going to draw a couple of reference angles and just kind of get an idea of what they are, and then we'll talk about why we would use them. So these four examples here, I want you to sketch the angle, and then it says find and sketch the reference angle. So see if you can sketch the first two, just A and B. So 150 degrees, negative 135. So sketch those two angles. Remember, it starts at the positive x-axis. It's a positive angle, it rotates counterclockwise. If it's a negative angle, it rotates clockwise. So Cole, if you had 150 degrees, what quadrant would that angle be in? Yeah, quadrant 2. So here's our angle in quadrant 2. It wants you to find the reference angle. So this is more of looking at your picture and thinking about how you can find this reference angle. Find and sketch the reference angle theta. So sketching, it's pretty easy. It's the angle that takes us from the x-axis, connects to the terminal side. It's going to be acute. So right there, that's finding it, or sketching it, not finding it. But we sketched it. Finding it means we want the actual value of the reference angle. Well, we just went 150 degrees. The reference angle is the leftover part that takes us to the x-axis. So Jack, what would that leftover amount be that takes us to the x-axis? 30 degrees. Because the x-axis is 180 degrees. And if I have 180, I subtract 150, my reference angle is that leftover 30-degree angle. The reason we use reference angles is because it then helps us find values of trig functions. A 30-degree angle is in the first quadrant, and hopefully you remember the ordered pair that's associated with a 30-degree angle more than you would a 150-degree angle. So that's why we use reference angles to help us find values of trig functions a little more easier. So looking at the second one, so you can see how it kind of changes. Negative 135 degrees. So I know it's negative. Leah, when it's negative, what direction do we rotate? Clockwise. And then where would negative 135 degrees be? Yeah, it's going to be in the third quadrant. So rotates clockwise. There's our angle. So negative 135 degrees. We want to find the reference angle, which takes us from the x-axis to the terminal side. It's connecting the terminal side and the x-axis together. So it's located right here. So again, it's a positive angle. So it's always positive. A reference angle is positive, coterminal angle, or I'm sorry, complementary angles are two positive angles, supplementary are two positive angles. So the reference angle is a positive angle. What would the amount be in between the x-axis and 135 degrees, Cole? Yeah, so you're going to take 180 minus 135. And what is 180 minus 135? Remember, it should be less than 90 degrees, 45 degrees. So that is our reference angle. It's a 45-degree angle. At 45 degrees on the unit circle, the ordered pair is the square root of 2, square over 2, square root of 2 over 2. So reference angle The goal of a reference angle is to help you associate other angles together. So part C, we have 9 pi over 4. I have a little sketch here. Really remember there's always a circle going around. That's a crappy circle. There we go. So 9 pi over 4 means I need to go 9 pieces. There's 8, and then 9 takes me back into the first quadrant. So 9 pi over 4 goes all the way around, and then it goes a little extra. The reference angle is the part that connects us to the x-axis. So Jack, what would the reference angle be in this? Yeah, it's pi over 4. I went 1 piece of the pi to get to my reference angle. Less than 90 degrees or less than pi over 2 since we're in a radian value. Questions? Let's change this last one here. We'll scratch this off. I want a different example right now. Let's say, how about 5 pi over 3? So I just came up with a different example. When we have pi over 3, remember we're not counting the y-axis. So I would draw starting positive x, going 5 pieces of my pi. 1, 2, 3, 4, 5. So that's the angle, 5 pi over 3. The reference angle, always positive, takes us from the x-axis to the terminal side. So again, it's that leftover piece. And you can just look when it's in pi. I can see I have 1 pi over 3. I know it's rotating in the negative direction, but by definition, it's always a positive angle. So pi over 3. Exactly. And so we've been referring to them as the family of angles. So any pi over 3 angle has the same ordered pair. So Jack said anything that had a pi over 3, a 10 pi over 3, a 15 pi over 3, a 275 pi over 3 is always going to have the same reference angle as pi over 3. So Jack, with the pi over 4, could we say the same thing? Yeah, any angle that has some kind of pi over 4 always has the same reference angle. So we've been always saying, like, if it's a pi over 4 angle, it has the same value. And I call them like a family of angles together, but they're really called reference angles. So when you're looking at it in radians, whatever that denominator is your reference angle. Questions? Anybody at home have questions? All right, so when you look then at the next example, reference angles help us evaluate functions. So let's go with what Jack said. We have the cosine of 4 pi over 3. So without doing any work, doesn't want to work. We know that the reference angle is going to be pi over 3. So the denominator tells us the reference angle. But we need to know the location of the angle so that we can kind of decide, is this positive or negative? So 4 pi over 3, 1, 2, 3, 4 is located right here. So pi over 3 is the reference angle. Every angle that's pi over 3 has the same ordered pair. And that ordered pair is 1/2 square root of 3 over 2. So any angle that has a pi over 3 will always be 1/2 square root of 3 over 2. So any reference angle that contains a 3 in the denominator would have that same ordered pair. Joe, if it's in the third quadrant, what's going to change with this ordered pair? Yeah, they're both going to be negative. So Joe, what is the cosine of 4 pi over 3? So we have that
Negative root 3 over 2.
cosine x or y.
Okay.
Yeah, it's x, negative 1/2. So cosine is x when you're on the unit circle. So the cosine of 4 pi over 3 is negative 1/2. But the pi over 3 part, that's the part that's important because that gives us the ordered pair. So the next one, we have negative 210 degrees. Again, make a little sketch. So sketch it so that you know the location of the angle. If you want to draw a circle, you can, you don't have to. I'll skip the circle in this one. So negative 210 degrees. Negative is clockwise. I know 180 is halfway, but we're going to 210, so we're passing 180. We want to know how far past 180 did you go? Jack, how far past 180 did we go?
30.
Yeah, we went 30 degrees past 180. To get to 210, I have to pass 180 by 30 degrees. That's my reference angle. Every 30-degree angle and pi over 6 angle have the same ordered pair. And that ordered pair is the square root of 3 over 2 and 1/2. But if we're in the second quadrant, Jack, which one of those is negative? The x. So we would have negative square root of 3 over 2 and 1/2. And then to find the tangent, I would take y over x. So again, like we've been finding this information. We did it in section 4.2. We did it again in section 4.3. We're looking at it again right now. So this information is just spiraling. We're just giving it a new name. So if I reduce these, I know my 2's cancel. I end up with 1 over negative root 3, which is negative root 3 over 3. So the tangent of negative 210 is negative root 3 over 3. I can find that by using the reference angle of 30 degrees or pi over 6. Questions? The last one is 9 pi over 4, which we actually graphed right above. So 9 pi over 4 we graphed to be in the first quadrant. So we know that it is in the first quadrant. And we said that that really was the same as pi over 4. Leah, do you remember the ordered pair for pi over 4 angles? So pi over 3 is negative 1/2 and the square root of 3 over 2. Pi over 6 we said was the square root of 3 over 2 and 1/2. What's the leftover ordered pair that we're missing? Cole, do you remember the ordered pair for pi over 4 angle? Yeah. So square root of 2 over 2, square root of 2 over 2. It's in the first quadrant, so it gets to be positive. And then the last thing we have to know is how do you find cosecant? Jack, how do you find cosecant? What's cosecant reciprocals with? Not the cosine, the sine. So if you know what the sine is, the cosecant is the reciprocal of the sine. Well, we know the sine is y and the cosine is x. So if we take the reciprocal of it, the cosecant is going to be 2 over the square root of 2. So cosecant is reciprocals with sine. So I know the sine is root 2 over 2. So the cosecant is 2 over the square root of 2. And then rationalize it. So we end up with 2 root 2 over 2, which means it's just the square root of 2 because these cancel out. Any questions? So reference angles really just group angles together to show you have this family of angles that have the same ordered pair. Reference angle is always positive and it's always less than 90 degrees. So the last question on here, again, kind of a summary. Actually, there's two. Let's go down to number 4. There's 2 questions down below, but let's look at number 4. Number 3 was the question that we pretty much did in the homework. So we'll look at number 4 for a minute here. Number 4 says find 2 values of theta. So this one is kind of doing the opposite. If you want to find a value for theta, what are you really finding? Peter? Angle. So most of the questions that we do want us to find the value of the trig function. This one actually wants us to find the value of the angle. So now we want to know what is the angle. We want to find 2 values of the angle in degrees and 2 values of the angle in radians. So we have the cosine being the square root of 2 over 2. So again, going back to my little diagram, I like to draw. It's always nice to have a little diagram. We want to find an angle where cosine is the square root of 2 over 2. And we just said the cosine is x. So if x is the square root of 2 over 2, y is also the square root of 2 over 2. But it says find 2 angles. So let's talk about the first angle. What angle would have a cosine being the square root of 2 over 2, Peter? It would be 45 degrees, or what about a radian? Pi over 4. So that's one value. That's really one angle because 45 degrees is pi over 4. They're the same angle. But it says find 2. What other location would give you a positive x value? Peter? In the 4th quadrant. In the 4th quadrant, we still have the square root of 2 over 2. But my x or my y value is negative square root of 2 over 2. So now we want that angle to be in the 4th quadrant because cosine can be located in the 1st quadrant and be equal to square root of 2 over 2, but it can also be in the 4th quadrant and be the square root of 2 over 2. The way you find that value is by using the fact that this angle here is going to be your reference angle. Your reference angle is 45 degrees. So if I take 360, because that's all the way around the circle, but I'm not going all the way around, I'm only going 360 minus that 400 or 45 degree angle around the circle. That gives me a 315 degree angle. So the reference angle, the angle that you're finding in the 1st quadrant, can also be used to help you find an angle in a different quadrant. So 315 degrees. Now I need to know what is it as a radian. Well, if I continue to make my little diagram here, as a radian, I can count pieces of the pi. I got 1, 2, 3, 4, 5, 6, 7 pieces of pi, or 7 pi over 4. So I have 2 angles in radians and 2 angles in degrees for this given angle. See if you can find the last angle. So this says the sine is the square root of 3 over 2. Sine is y. So now you need to think, like where would the y be negative on a graph? Well, the y is going to be negative on the graph where, Joe? The 3rd and the 4th quadrant. So my y is negative square root of 3 over 2. Hey, the bells are working. The x would be 1/2 or negative 1/2. And then you need to determine the angles that are corresponding with that. So the angle that would be in the 3rd quadrant, the angle that would be in the 4th. So we didn't get to that little exit ticket that I wanted to get to, but that's okay. We'll start off with it tomorrow. Have a fantastic day. Anyone at home, questions that you want to ask?
No,
Have a
thank you.
great
Have a good
day.
day.
Thanks, you
Have a
too.
great day, Miss.
Thank you. Bye, have a good one.
Oh, see.
See you, Peter, you too.